in a couple of Silicon Valley guys because we had to do that. So what we have, David Hampton is the CEO of M87. M87 actually came out of UT. The idea of what M87 did was one of a graduate student who had an idea on how to deal with the control channel and how to really maximize system capacity using it, and Dave will explain that a bit. Next to Dave is Tanuj. Tanuj is one of our Silicon Valley guys. Tanuj came up with an idea of how to deal with lighting system, heating systems, how to manage them very effectively. He named his company Enlighted. He'll talk about that. Ravi, I've known Ravi for years. Ravi Subramanian is the CEO of Berkeley Design. They test things. He knows testing intimately. Ravi and I have coffee, or actually have breakfast regularly at a coffee shop down in Burlingame, and we compare notes on what's going on in the industry. We've been doing this for years, Ravi, right? Daniel Cooley, he's the one with the really quiet shirt. Daniel is with Silicon Labs. As you know, Silicon Labs has been a major player in IoT, and Dan will talk a little bit about that. And then Ed Hemphill. Ed knows a lot about standards and how to make things work. He worked at another company. Remember you told me, I can't remember right the second.
Life Science.
And then he founded the company he's another startup here in Austin, and he's helping to solve the interoperability problem. So, guys, let's why don't you get a brief rundown of your company, its role in IoT, and then maybe a little bit of your own background and how you got involved. And Dave, we'll start with you.
Okay, sure. Is this on? Yeah. I'm David Hampton. I'm the CEO of M87. As Brian mentioned, M87 is a software company that's actually commercializing technology that was invented here at UT. A PhD student, Vidur Bhargava, who's in the audience, and Professor Sriram Vishwanath, who's here as well. Our software, you can think of our software as routing software. It enables multi-hop device-to-device discovery and connectivity. So right now, we're applying that technology in the cellular world to improve coverage and capacity. And myself, I'm actually a UT Macomb School graduate as well, so we've got a pretty deep UT connection.
Tanuj.
Hi, at Enlighted, we are turning lights into sensors. So we are deploying the world's most advanced wireless sensor network that's allowing us to bring commercial real estate into the world of IoT. My background is computer science. I've been in networking companies and security companies for the last 15, 20 years now. The key to what we have done is lighting is the first application we have deployed, and that provides energy savings that justifies the deployment of the sensor network. What we are now seeing is that that's just the tip of the iceberg. We are starting to do HVAC optimization. The energy part is maybe 3 to 10 cents a square foot a month. The human being that occupies that space, the rent for him is about $3. So in a space that's like our office, 20,000 square feet, if we were to fit one more person in that space, we would eclipse the savings from any energy measures we would put in. So that's the second set of applications we are going after, is where we can, in real time, visualize the space, see how your assets are being used, and figure out where the inefficiencies are. There are a whole bunch of other applications in the life safety, retail tracking. It just gets exciting from there.
Ravi.
So Ravi Subramanian, formerly Chief Executive Officer of Berkeley Design Automation. Company was recently acquired by Menor Graphics. Menor is a leader in providing hardware and software solutions for electronics systems and semiconductor companies. And in the IoT space, we enable the design and the verification and implementation of IoT systems on a chip, ultra-low power, including embedded software solutions, development solutions, and the software required to build flexible boards and new types of printed integrated circuits on flexible surfaces. And software is found in virtually all ends of the network, from the core to the edge. And my background is primarily started off in statistical communication theory and signal processing, then moved on to semiconductor design, and then using advanced applied mathematics techniques to do verification of integrated circuits.
Excellent. Daniel?
Hi, everyone. So my name is Daniel Cooley, and I run the MCU and wireless group at Silicon Labs, based here in Austin. So I'm keeping it weird today. And Silicon Labs is a semiconductor company similar to TI. We had a speaker a couple speakers back. And we are primarily making mixed signal and wireless devices. And that's where our play is in the IoT. So we're the things. That's my world. We're big in some of the standards where we have presence in the bodies and in the microcontroller business and sensors as well. And a little bit on my background. So I'm a UT grad as well, and spent some time living all over the world in Europe and Asia. So I've seen the applications, I've seen how things really get done, and the IoT is finally here.
Excellent. Ed?
Sure. My name's Ed Hemphill, co-founder of a company called Wigwag, which is a startup here in Austin. So Wigwag really has two businesses. We make, if you go to our website, you're going to see a home automation hub. And that hub is not too dissimilar to something like Revolve or SmartThings that you may have heard on the market. The difference is our platform's based on open source. So our underlying engine's based on Node.js, which we have a runtime called Device.js. And so I think everyone can agree that the way a major change in IT and software and hardware happens is when you have a huge amount of open standard behind it. And so part of the reason the web got so big is all of us had a web browser, right? And that web browser, for those of you in the early days, was Mosaic, if you remember that, and later became Netscape and Firefox and Internet Explorer and so forth. And so what we essentially do is Device.js is like an execution engine or a browser for IoT. And so a second part of our business is we can use that Device.js and we can port it to different development platforms, different routers, different other devices. Also a UT grad, Macomb School, and computer science undergrad.
Okay, guys, so I've got about 6 questions, and then we'll definitely want questions from you in the audience. I'll target one of you with the question to start, but please ask all of you to jump in. So Dan, you nodded your head. You're actually number 1. You're the first one. So I had coffee with your boss, Tyson Tuttle. He just broke it. With your boss, Tyson Tuttle. A couple months ago. And Tyson talked about the fact that for Silicon Labs, I think it's about 25-30% of your revenues now can be tied to things that are IoT, and the rate of growth of that is about 40%. So you guys are clearly seeing annualized some numbers. So what is your view of the ramp in IoT, and what are the key gating factors for IoT adoption?
Okay, so those numbers are right. I'm glad he's giving you the right ones. Tyson can be known to embellish sometimes. So there's really 2 questions you're asking is what's driving it today, yep, and maybe what's some of the bottlenecks that exist.
Yep.
Well, what's really driving it are some of the standards that are coming out right now. We heard there's a lot of standards. I mean, that's can be seen even as a bottleneck right now, but these standards didn't exist years and years ago. Every company out there had to develop their own proprietary stacks, and that just doesn't scale. So it wasn't open. We're seeing applications in the IoT such as lighting. That's a really big one. And we're seeing home automation. So not just lighting in the home like the Philips Hue that you see on the shelves at the Apple Store, but lighting in the industrial environments, wireless sensor networks, the electronic shelf labels that you see a lot in Europe, less so here in the US, are now sensor networks that the stores are being able to monitor down to the shelf, who's walking by or how many people are walking by, what's the temperature and humidity out there, are my goods spoiling or not. So we're seeing a lot of, I say the last one because I don't want to take too much time, are the metering networks and the smart grids. So those have been kind of at the forefront for a while now driving this, and you see what's going on in the UK and China. In the US, you saw the Itron video a little while back. So the metering guys have been needing this for a long time, and they developed some of their own protocols, but now are relying on some of the standards that are out there today. 15.4G, G is one of them. I'd say the bottlenecks right now are still pretty simple. Power consumption is one of them. You know, if battery technology got 10 times better overnight, you would see a pretty dynamic shift in the market. So all the semiconductor guys like us are trying to race to enable the chips to power off these things for longer. So power consumption is one of them. Standardization is a bottleneck. Okay, there are too many standards out there. Companies like Wigwag are abstracting this, so that's great. And you're actually starting to see a lot of standardization above the networking stacks. So the all joins, the home kits, the OICs, these aren't Bluetooth and Zigbee. They're above that. And the last gating item are cost. It's pretty simple. The cost of these chipsets has been too expensive. If every chip is $5 and you have 50 billion of them, well, you can very quickly approach the GDP of some countries. So the cost points are dropping as the markets are taking off, and we're seeing the positive feedback loop that you expect when that happens.
Ed, I'm sure you've got some comments on this.
Sure, yeah, absolutely. The stuff he made about statements he made about all join and stuff like OIC that just came out are really changing the industry, and I think you're going to see more of those. So one of the big challenges is every major corporation has a vested interest in something that they want to do. So, all join formed by Qualcomm clearly has a big vested interest. Qualcomm has a big vested interest in Wi-Fi and in some other technologies, and so does everybody. So I think it's going to take time before those layer 4 and ups application standards get to be, we end up with a couple of 2 or 3 really big ones. And then the other challenge you have in IoT is it's not just the protocol soup and the big vendors that are out there that kind of have their own vested interests, but then you've got all these vertical segments too, right? So just while he was talking, he said, industry and home automation, they're just 2 entirely different animals. And so a couple of other startups down here, they're in industry. We don't play much in industry. Almost everything we're doing is worrying about home automation right now. So, and then there's all kinds of other stuff too. There's retail and so forth.
Who else wants to jump in here? Ravi?
So just a comment, if you look at the traditional hype cycle of the accelerated excitement and the peak and valley of disillusionment and then the slope of enlightenment, each of the verticals are going through their own hype cycle for IoT.
Yeah, very good.
IoT is in the market. It's affecting kind of everything out there. I mean, I get asked this question a lot by analysts, industry analysts, or financial analysts. What is the IoT market? It's affecting everything, and it's really the same things that have been happening for the last 20 years in process control. It was just done in wired fashion, and so IoT is more wireless when it comes to these kind of things.
Yeah.
And just to add, I think at the end you have to figure out the business model. If you can figure out the business model, you can make whatever price points work. So the way I think it's going to go is people will figure out vertically integrated business models, what's happening right now. And the people who are now ahead of the curve will start opening up their APIs, and a platform which will use data across multiple silos will make IoT a reality. And that will actually drive the costs down and make, have people invest in making standards across all the layers in the stack.
Okay, so we're going to open up our APIs, expose them to third parties, and what about security? What about people hacking your house and turning your music on at midnight, or turning your lights off when you're awake, or whatever? Or in buildings and doing, what about this? Dave, you guys work in the control plane, you understand some of that. Let's get your input on that.
Yeah, in our space, it's critical, right? We're enabling smartphones to connect the route data through each other. And so the device security is critical. The device all the way back into the core network security is important. We're not broadly in the IoT space on the medical side, but it's easy to imagine all the applications that have high value, and in our mind, the high value applications are where a human interacts with a sensor. That's pretty sensitive information. Ours is highly sensitive. Smartphones have, as several people have mentioned today, they're the most important things for people. I love the example about when people think they've lost their phone, they do go into slightly a panic. It's the same thing if they think there's been a data breach of their phone. To add to that, once there's medical, information on people, I think the sensitivity is going to be very strong.
And we're building all this stuff into the chip now. So you have to take this at the software application layers, the networking standards themselves, but all the way down into the chip, into the silicon itself, the crypto engines that are down there. We're going to be making elliptic curve cryptography on tiny little MCUs that are coming to do things you do specifically in software so that people can't see what's going on in the hardware. And ARM is making new cores that are going to be protecting people's code even better than they have in the past. There's a lot of things that are ongoing right now, which is another way of saying that it's going to be a couple years before you start to see the really secure hardness come into the consumer space. It's mandatory in medical, it's mandatory in military, it's mandatory in some industrial ones. But in the home, I'm waiting for the YouTube video of someone to walk up to a wireless door lock and unbreak it with their phone. To be honest.
It's happening already. They're opening up in Europe. There's an entire hotel chain that has Bluetooth enable doors, and there is a group of hackers that will open the doors at 9 p.m. and they target one hotel at a time. And somebody in Europe was telling me the people just leave their space and they have security because they tell them upfront that we're going to do it to you. So
Or they could
it's
just kick it open. It's the way the military does it. But another big problem with it too is on the topic of security is discovery and provisioning. So when you add security into the mix, you just made the discovery and provisioning even harder. So you kind of have to do them all at the same time, I would say, or otherwise you're going to have this big problem because you can't. You don't know if stuff's even out there. So this is one of the big problems. Like I heard a lot of talk earlier in the last couple of presentations about Mac and PHY layer stuff, which is cool, but the real problems are beyond that, which are those are obviously significant issues. But the other problems are discovery, and so discovery is usually like a layer 4 and up thing, and we don't have really any standards for that, even in protocols that are already widely used, like 6LoWPAN. So.
And just as a side, we had to solve each of these problems when we deployed our systems. And being a VC-funded company, the first thing they asked us that how will you protect your CM from copying your sensors and having ones that are a fraction of the costs out there. And we had to go down and have our chip manufacturer program half the software, a spy flash having half the other software, a key with the CM and parts of the key with somebody else. And when the system comes together, kind of like a trusted platform module, the whole thing works. And then the chips are also locked down so that they cannot be read back and only erased. So we started with all that 5 years ago, and when I tried to explain it to the lighting world, they said, what are you talking about? They just didn't get it. So most of the products you see out there are susceptible to replay attacks, denial of service attacks, just by a trivial hacker. So it worries me that the industry that was bringing IoT had no background in computer networking or security, and that's going to be a challenge because these hacks are going to happen.
Yeah, just to give you an idea, we have those of you that get our signals and noise, on Monday's edition, there'll be a transcript from a tech talk that we had on Tuesday of this week with the CTO to the CIO of Coca-Cola. In that transcript, he talks about that hack that happened to one of the large department stores. The hackers got in through an air conditioning port and they got hold of the code that some of the passwords that the maintenance person had on them, and with those passwords they went all over that department store's web and got all kinds of data, and that's how they got in. So it's got to be very robust, and you've got to think of most angles because the bad guys are for sure. So let's move on to the next one. The IoT turns anecdotal information into statistical data. How does the industry leverage this? How does your company leverage this, and what kinds of new businesses and features will be driven by this new data? Tanuj, you already have that, so we'll start with you.
Actually, let me tell you a story over here. About 2-3 years ago, we were in a staff meeting, and it was that time where you were not allowed to open your laptop. So we have these staff meetings where laptops are allowed or not allowed, depending on people's focus. So it was that time when laptops were supposed to be shut. We entered the room and found out that the projector had gone missing, so our CEO said, okay, open up your laptops and follow my presentation. Curiosity got the better of me because I remembered that around at 7 o'clock last night,
I think you need to talk into the mic.
the projector was there. So I animated the entire floor because we have our system installed in our office, and I saw that at 6 a.m. that morning, somebody walked in through the front door, walked to the back of the conference room, and left. I said, that's very suspicious. So I Skyped our office admin and said, who badged in at 6 a.m.? It turned out it was a director of the company, and I said, wow, that's strange. So I went in and looked at his Outlook, and I saw that at 7:30 he had a meeting up in Redwood City. And I said, oh, okay, so 6 a.m. he's driving up there, he's having his meeting, 1 hour meeting, 8:30. He'll probably be back here by 9:15, and I looked at the watch and I said, guys, the projector is going to walk in. And in 5 minutes, the guy walked in and said, did you miss this? And everybody in the room was surprised. How could I tell that this is going to happen? And we just have these things where we are installed in a showcase floor in a large Fortune 500 company, and the guy is very proud of his hoteling concepts and how the users are so happy and he's getting maximum utilization on the floor, and he installed our system, and he asked us to run an occupancy report on it. And we showed him that 25% of his floor, open area floor, was never occupied. People just avoided that space. And he went in and he looked at the walk patterns and he said, oh my God, I didn't know this was happening. And here he was boasting about the space, whereas we showed him that his space, peak utilization of his conference rooms, his private offices and his open offices was 55%. And that's kind of where the value of the system comes in, is where you can actually, convert what you think. And managers always complain that they need more space. Conference rooms are never available. And there's a Wall Street Journal article about that said they are hoarders, people who keep reserving conference rooms. They're squatters who sit in conference rooms that are not reserved. They're overstayers. And they're autocrats who kick people out. But conference rooms, meetings are going up. Conference rooms are needed more. And systems like ours actually can tell you whether the conference rooms were actually being used or not, because people walking around always claim they can't find a conference room. And most of the time, there are reserved conference rooms that are not being used. So we free those conference rooms up. We have started to work with another company that says if there are people overstaying, they're welcome in the conference room, and you're waiting outside, you can press a button and it'll start flashing the lights on them. And depending on how aggressive you want to go, it can turn the lights on and off every second and force them out. So there's just a lot happening, and the very fact that we can show it, the facility managers most of the time say they know that was happening, but they just don't have the data, because people will tell them these stories that they're walking with a high-end client and couldn't find a conference room for 10 minutes, and the deal didn't happen because of that. But we have the data, and they actually love it that we can show that it's just underutilized assets. And it falls into one or two categories, and it's more of a social problem to solve than a real asset problem.
Just give you an idea, Tanuj has sensors that go up in the ceiling panels. They're either next to the lights, or actually it's got a few lights where they're in. There's sensors that measure. What are they have 3 items in them.
They have motion sensing, they have ambient light sensing, temperature sensing, and they also meter the fixture they're attached at. So
that is how all that data gets generated, and this is what's coming of it. Anyone else with some views on that? Okay, let's go on to the next question then. Ed, this is going to be for you. How are standards evolving, and how will they impact IoT adoption?
Sure. So, I come at it from the viewpoint of Wigwag and automation, both in offices as well as in homes. I think you're beginning just to see the beginnings of these. So, for instance, Wigwag just this month joined Thread, which Silicon Labs is one of the founding members of. So something like Thread, I don't know if you've heard of Thread. So Thread is a 6-LoWPAN standard that is being pushed by Nest and Silicon Labs and Freescale and a couple other folks, and Samsung, not to mention them. And what it's going to really do for a consumer, though, is it's going to give a badge on a product that lets that consumer know that that product will truly work with the hub or the thermostat or whatever it is they have. And so just in pure home automation, you're kind of seeing these 2 competing viewpoints going on. One of them is that devices will work together and there won't be any one center point that will kind of control everything in the home. And the competing view to that is there will always be some sort of hub or product which will be in the home that will sort of be the brains, and everything will kind of work for it. But in either case, consumers really need to understand, will the product work with the other products that I have or not. And so if you just look at home automation alone, and these guys have a whole another host of other protocols they work with, many of which I probably don't even know about. You've got Z-Wave, Zigbee, Thread, you have InOcean, and a number of other protocols that certain groups of people, or if you talk to them, they will tell you that is the only way to do home automation. But then if you go over to the other alliance or the other group of people, they will tell you, well, their protocol is the only way. So I think a real driver is going to be both the standardization of layer 3, 4, 5 kind of protocols, and the branding of those protocols that will allow consumers to know that stuff will truly interoperate with the other things they have.
Dan, you've got to have some comments here.
Yeah. So this is where we live our world at Silicon Labs every day. We hire more software engineers for networking now than anything, and we're a semiconductor company. It says where things are going here. So there will be a coexistence of a dozen plus standards that are going to be out there. And we all say standards, but some are proprietary and some are actually standards, right? I'm going to call all that standards here, depending on the application. So because of what you're seeing at the higher level, application layers, the underlying protocols beneath will somewhat be abstracted, and the right one will be chosen for the right job. In the home, what you're going to see happening is you're going to see a low data rate point-to-point standard, a high data rate point-to-point standard, and a mesh. Okay, the low data rate might be Bluetooth. In some situations, the high data rate was probably going to be Wi-Fi, and the mesh, who knows? Jury's still out. You got Z-Waves, you got Insteons, you got Thread, you got Zigbee, you got a bunch. In the industrial space, it's going to be a lot slower because it's much more conservative customer base. They have much larger deployments. They don't pick up things off the shelves and just buy it one at a time. And there, the proprietary standards are going to reign for a long time, 10 plus years. And the companies that have invested heavily that drive a lot of volume in lighting, in industrial automation, they have developed their own wired and wireless proprietary stacks, are going to live for a long time. So eventually things will shift over into the standards, even in the industrial side. Healthcare will be another one that will take a long time. But what you'll see ultimately taking over in the consumer will make its way over there eventually. I guess, that's enough on that.
Yeah, Ravi, the testing guys are always early in this stuff. What's your view?
Right now, I think, I agree with what was stated regarding regarding Wi-Fi and Bluetooth and the division between, if you will, the home and personal choice types of devices versus the industrial or commercial automation. What we're seeing is a lot of anxiety about verifying and testing a lot of these systems. The anxiety comes from the complexity, and the anxiety also comes from the fact that, going back to the hype cycle, I think each of these vertical industries is going through their own hype cycle. And as it goes through the rise and the peak of expectation and the valley of disillusionment, many of these standards get shaken out, and many winners get determined. In the industrial area, almost invariably proprietary types of standards. And then a whole proprietary ecosystem of products around that start getting defined, and then things start getting solidified. So I actually think in the industrial, or if you will, industrial automation lighting in enterprises where proprietary systems can thrive, they're going to be riding out of that valley the fastest and the first. And we're going to see the largest deployments there, and we're going to see the first, if you will, real platforms. And by platforms, I mean the systems that semiconductor companies build that now have silicon, software, security, tailored for that vertical. And in the areas where it's still a shootout, there's just a lot of anxiety, and Silicon Labs is not unique in hiring more software engineers now as a semiconductor company, because that's basically the increasing point of tension on where you will be able to win. And you have to ride multiple horses in the valley of disillusionment, because only a few of them will win, and you can't afford not to ride every horse.
Tanuj, what about your, well, go ahead, Danielle.
Just real quick comment, and I meant to say it earlier as a bottleneck, and I forgot. It's the verification of this stuff. Like, we're taping out or PGing a chip right now that is having to be verified for more than 10 wireless networking standards, and on an FPGA with an over-the-air capabilities, and interop, and all of that. A verification of this really is a bottleneck for the semiconductor guys, and we need better tools.
Amen.
Tanuj, what do you see on the lighting side? Can you talk about that?
Actually, I completely agree with both the speakers. In the commercial sector, industrial sector, where we are, the current standards are not enough. The kinds of deployments we have done could not have been done with Zigbee and other protocols. It was simply too expensive and wouldn't scale. The amount of data we are sending is not 100 bytes of lighting data. I heard somebody else say command and control. That's not what IoT is about. The sensors we are putting out there, you get one chance to put a sensor up in the ceiling. You might as well put as much sensing capabilities as you can. So the data you send is not simple on-off data. we sample our motion sensor 65 times a second, and then we have a DSP code written in software that figures out signatures, kind of like in an intrusion detection device, to figure out if somebody is walking, somebody is running, or somebody is typing, and the sensor adapts to it. So it gives there's no more hand waving if you install our system. So it gives the persons under the light a very good experience, but it also creates a shitload of data. It's not lighting data, and that's kind of where what we have done, we had to do. So we are waiting for a protocol, not to do, small packet bytes, but 100 bytes. So just to give an example, 100 bytes is what lighting would create properly in an hour. Today, per sensor, that is per light fixture, we ship about 10 kilobytes of data. We generate over 10 megabytes of data per sensor, and each sensor is with every light fixture in a building. So the volume of data we create is huge, and what you can do with it is amazing once you start understanding. It's a software platform that you have deployed. It's not a one-time sensor. Again, it's the best of both worlds. 100% reliability can never be achieved with wireless, just can't be. In the unlicensed spectrum, you can always jam it. So wired has to be there, so our sensors are wired to the fixture, controlling it right there, so you can't jam it. Wireless is used for data gathering, tuning, and other applications, changing configuration, so it's non-critical. The hub and spoke architecture he spoke about, whether there's a controller or not a controller. We have a controller so that the data goes out into the cloud, but it's not really a controller. If you press a wireless switch in one of our rooms, it does not have to go back to a controller. The message is sent directly to the sensors overhead. And the switch is battery powered. It needs to live for 10 years. The sensors are line powered, so they can do what they want. So the application, the protocol can't scale to do both things at the same time because they're totally different devices. One device is always in deep sleep. The other device can transmit and receive freely at will. So when we look at the standards, they have not yet targeted the applications, and the applications are so diverse that it'll take time. So I think in the industrial and commercial environments, it'll take time before the standards catch up, simply because they haven't seen or understood the use cases fully.
Yeah, fair point. Dave, you're dealing a lot with this in your technology and getting it adopted with the carriers.
Yeah, for sure. And in our world, that's more, coming standards that make sense for us for device-to-device on the smartphone side are like LTE Direct that Qualcomm's developing. But yeah, it's definitely important. I think the previous speaker from TI said it really well. I can't remember how many on the list she said of standards there are now, but it makes sense. If there's going to be 25 billion connected devices, they don't all have the same needs. So I think there's going to be a proliferation of standards. And in wireless, where we work on the smartphone side, they're a little bit more defined, but connecting all those devices amongst those standards is a challenge.
Yeah, I would just, my input would be watch what types of sensors and capabilities you could put on smartphones. That'll tell you a lot about what's going to be, at least in the home, what's going to be dominant. A couple more questions, and then we'll start pulling questions from the audience. So, Ravi, we've kind of talked about this a little bit already, about which wireless technology do you think will dominate? Are we even close to figuring that out?
I shudder to answer a question with the word dominate in it, but at least what I think will be the early ubiquitous ones are Wi-Fi and BLE. And what's probably not well understood is the point earlier made by this gentleman regarding power. If you look at off-the-shelf Wi-Fi solutions today, the power consumption is simply unacceptable for IoT application, whichever vertical you pick. The power needs to come down almost by a factor of 5 to 7 is what we're hearing from customers on what they need a Wi-Fi transceiver to be able to do. So you cannot just take a combo chip from vendor XYZ and put it and create a solution. So those are the main wireless standards we see. And I think these have to be reinvented for the low power mode. If you need something to run for 10 years on a cell battery that you buy at Radio Shack, the whole game of how you do in transceivers has to change.
Dan?
Yeah, I couldn't agree more with that. And it's not a factor of 5; it's more a factor of 10, and that's what we're really driving to right now. What you're able to do with the cores while they're off, being able to do very fast sensing of preambles to allow your receiver to sleep, because it is the receive current that dominates the power consumption, at least in a battery-powered device. Faster, efficient cores for doing more faster while you're on. It's not about maybe it's not about your peak current, but it's about the total joules or coulombs that are pulled out of batteries. You're going to start to see a lot of new semiconductor content chips proliferating the market to address these things. I mean, to date, most of our industry has been driven by either PCs or handsets. Okay, so the things that you see happening there weren't necessarily the most power constrained. Okay, certainly not in computers that are plugged in all the time, and your handsets, at least these days, have giant 3,000, 4,000 milliamp hour batteries inside of them. Well, try doing everything on 50 milliamp hours for years, right? Or the metering guys who put something down in the ground and need it to last for 20 years. I mean, we put chips in meters that are supposed to last 20 years. So how do you do that, right? When your overall power budget is on average 3 microamps for years. So how you manage the power is just as important as how you transmit and what you choose to process locally on a device as opposed to sending it out to some central hub or even the cloud. These things will have to be thought at the system and the architecture level, and inevitably it gets to another statement is the business case around all this. If you can't explain that to the customers, they don't give a crap about the power.
I'm going to take a wild guess, which I think some of you will agree with. I think it's going to be, we're going to figure it out in the next 5 or so years in terms of the big standards that'll be out there. In the home, unlike industry, in the home, you've got to have a couple of key standards because you can't get commoditization and you can't grow, you can't do industry creating size markets unless you have standards. So no one would be sitting here with a laptop if we didn't have the Wi-Fi standard. You just wouldn't have bring a laptop in because it would be useless because you wouldn't be connected to the network. So for it to get really big, you've got to have a standard. And so I think it's going to be, personally, just my guess is an IEEE IP-based standard of some kind. Well, maybe, I don't know. Cisco doesn't think that. But possibly Thread, possibly something else. But I actually disagree with Bluetooth. I don't think Bluetooth is going to have much of a role in home automation purely because it's not truly open, and the other problem with it is it's not meshed. If you think about power consumption, remember that if you want to decrease power consumption, you can also not have amps. And to not have amps, you probably need mesh, at least even in a smaller space, right? So you need meshing in order to be really efficient.
Yeah, I think Dave would agree with you on that one.
One comment for Bluetooth is it helps solving the commissioning of a device.
It does.
Because you have your handset.
Anyone's used a drop?
Yeah, they do that well. Yep.
Pardon me?
No, yeah, absolutely. That's one thing they do really well.
Yeah, the install base of Bluetooth is high because we all have it in our pockets. I agree on the meshing piece. I think meshing is absolutely critical because it's the only thing that allows scalability, and we have to have these things scale. But solving that commissioning and authenticating a device to plug into a network is not the easiest without some rich interface behind it. Even NFC might have a play here.
Oh, yeah.
Dave, you had a...
I was just saying each of these standards was built for something else, and we are trying to shoehorn it into the IoT world, and it really doesn't fit. As you said, Bluetooth was meant for pairing your phone in the car and things like that. Wi-Fi was meant for laptops. None of them actually fit. Zigbee or IEEE 82.15.4 was meant for sparse mesh networks initially, and they are trying to fit that in. But the problem with that network is the cell phone guys are not supporting it. So at the end, I think it will be cell phone driven. If the cell phone, I think it has to be built ground up, and maybe if a 82.15.4 standard is, if chips are put into the cell phone, that will make it very clear who the winner is. Till then, we are, Wi-Fi, as you said, power and cost, even size. Wi-Fi chips don't have the headroom. You need to put another coprocessor with them. So the size of the device goes up. Bluetooth, again, lots of complexity, wasn't built for it. So we are in a world where we are trying to fit what we have, whereas none of them really fit. So I think at some point, Nest or Samsung or Google, somebody will step up and say, okay, we'll enable a physical layer that will be IoT compliant. And if they do that, overnight the world will change.
And in the meantime, we'll have to see how guys like Siemens and Marubeni and Mitsubishi behave, because most of the industrial systems are put in by those guys.
Yeah, no, but those will still be proprietary, I believe. I mean, that one you'll always have to have a layer, that will interact with it through some kind of mediation or gateways. And you'll have to keep them siloed because, one, it's too dangerous, and two, they have no security. So,
Good point.
Just my last comment on this with regard to carriers. So they're starting to get into this with Sigfox. I don't know if you guys have been seeing that, but it's a sub-gigahertz kind of ultra long range connectivity standard. Well, not standard, it's proprietary right now. But they're starting to, announce that they're going to be deploying these kind of networks. So I'm curious. I'm also very curious to see what these carriers end up doing, because what they decide is going to drive a lot, because they're so big and everybody has a phone.
And I think the point Brian made about what goes on the phone is key. So two things we're really interested in are 802.11h, which is mentioned a couple times, and then also 802.11s, which is the Wi-Fi, if you don't know, the Wi-Fi meshing standard. So two of those, they've been around a little while, but they're they're still in the early phases compared to other stuff.
Yeah, our Qualcomm guy's gone here, but I can tell you, given I cover the company, Qualcomm's putting a lot of work around or behind 802.11ah. So, Dave, did you have a comment?
No,
Okay.
I think we would violently agree.
All right, so last question, and then we're opening it up for the audience. Dave, we will start with you on this one, and this is the open question. Which will be the most popular IoT applications? Plural.
Yeah, well, in a self-serving world, I guess we would say, essentially M87 software by enabling what we kind of call a personal mesh amongst smartphones and starting the data routing amongst phones and essentially bringing the 8 billion smartphones that are forecasted to come online into the network infrastructure, we think is a tremendous high-value play. In our trials, we see coverage gains for people, for device-to-device connectivity, as well as capacity gains. And that's a huge industry, many hundreds of billions. Beyond that, on the IoT side, I would, this is purely speculation, but I would think medical would probably be, just because some things can be hooked up, like your anecdote about the air conditioner, my guess is somebody's now thinking, why the hell did we hook that thing up? How much money were we supposed to save with it? What was the business model for hooking that up now that we've had this data breach, right? So my guess is that people, a lot of things that people think will be hooked up that don't really have a business case to be hooked up will not be. But
Tanuj?
medical is clearly a high value, tremendous amount of cost in our economy, and probably a lot of things will make sense there.
Okay. Tanuj, you're next.
I would answer lighting, but anyway. I think it will be around the individuals and productivity of individuals. I think those are the IoT applications that will first happen, and mostly powered by cell phone interactions. I just think that's where the IoT world will take off, because you have a mobile gateway that is huge, and it has access to the cloud everywhere. So I think applications that tie your environment to your cell phone and move with you will be where the quickest maximization of value will happen.
Ravi?
Yeah, I'm wary of any personal applications that'll thrive based on security and security concerns. But ultimately, I think personal health and personal fitness is where there's a lot of potential. Even today, if you're training for a marathon, you can have an online coach who's getting all your data as you're training and telling you how to change and adjust your patterns, and work with you real time, if you will, through your training program. And if you do that for various sports, that could get everybody to be at a higher level of physical activity, which will only be good for the world.
And then there's this social networking element of that as well.
Indeed, indeed.
Yep. Crazy shirt.
I would say, I don't want to answer it which ones are going to be first, but which ones are going to win out in the long run. You got to look at where all the money is spent today. Okay? The IoT is not going to double the global GDP. Okay? Maybe in 100 years it will, but not today. So you got to look at where the money is being spent now, whether it's energy management and distribution, medical, security, consumer goods in the home. There's a lot of money spent there. These are the applications that ultimately are going to be, the costs are going to be driven down, or the value is going to be increased. You look at the amount of energy spent on lighting globally. You look at the amount of energy spent on spinning motors. You guys, it's actually phenomenal how much of our energy is meant to just spin motors. Let's spin them more efficiently, perhaps, or at the right times. And in the medical arena, it's not going to necessarily be in the hospital room. Okay, it's very highly regulated there, but more about maybe aging in place or as a complement to the hospital environment, so you can stay in the home. And your insurance company says, if you're willing to put this kind of stuff in your house, well, we don't have to pay for the expensive hospital bed, right? I think those are the applications that are really going to end up driving the value out of this. There's certainly the consumer aspect. People just want certain things. They want more convenience. They want more efficiency. And the last one is automotive. It's something we haven't talked about here. But your car is essentially now just a supercomputer on wheels driving around. And I promise you, there's, Silicon Labs isn't as strong there as Texas Instruments or Freescale or some of our other competitors. But in the automotive arena, there's a massive amount of innovation going on in and around and how the car plugs into the IoT.
Ed, you're last.
Sure. I think a couple of things. The body area networks, which I don't know if they've been mentioned here at NCL presentations, but that's essentially where different devices on your body can communicate with each other, will really bring a huge amount of benefit to the medical community because it enables preventive care. So I think that's going to be a huge thing that will be good for us. Of the industries mentioned, I'd say, I definitely put my money behind healthcare simply because there's great needs there. But frankly, I think the best applications haven't been invented yet. And the reason for that is there's just not very many developers that know how to do an IoT application. And that's why you see a bunch of companies that do vertical solutions or cloud to metal solutions, because you have to do it that way today because it's hard. Right? So imagine if developers had to go and build the laptop, the operating system that goes in the laptop, the web browser, the software that goes in the cloud, the servers, and the wireless protocol. If they had to do that whole thing, that whole stack, it would be very slow to innovate. So I think what we're going to have is a lot of standardization around programming methodologies and standards that will allow people to really quickly create IoT applications, and I think you're going to see stuff that we haven't even dreamed of yet.
That's what ARM's trying to do with Embed OS, the Embed device servers.
Yeah, if you don't know what he's talking about, the Embed website for ARM is a standard and pretty interesting what they're beginning to push. They kind of have a vision there.
Okay, so we have time for a few questions before we go to break. So right here.
So my question is about any of you guys think about 5G, millimeter wave, or UWB. What those technology, their role will be playing in the future IoT, maybe.
5G and ultra wideband?
And also millimeter wave.
Okay. Millimeter wave, 5G, ultra wideband.
I'm going to bow out.
Broadband.
We don't have much play there at Silicon Labs.
And what we're seeing in terms of IoT and standards people are looking at, even in some advanced research labs, I think we're seeing millimeter wave, especially in the automotive radar area, tremendously. And that's 60 and 76 gigahertz for car-to-car radar. UWB and 5G right now, no. It's really a more focus on trying to commoditize existing well-understood protocols. By commoditize, I mean drive down cost, power, and silicon area, or not silicon area, but power, and potentially trading off area for power in older silicon technologies.
But also, I think, some of these broadband connections in the home, making it easier for you to upgrade your systems and move them around and put them where you want them.
I will say this about that, Brian. One other thing is with the wireless, on a side note to that, is anything that spread spectrum, I think is going to begin to be highly interesting because the frequency, it's getting to be incredibly crowded, right? So 802.15.4 doesn't play well with 802.11. So and that's a lot of what we've talked about in here, right? So the problem is if you go to a trade show, everything 802.15.4 is going to be sitting on channel 20. That's because it's sitting between 6 and 11. So if we can start getting wireless technologies that are spread spectrum that allow us to hop around a lot, I think it'll be very strong.
Cognitive radios. So over here.
Thanks for the very interesting discussion. You guys have highlighted many of the technical challenges and also business challenges really well. I'm going to bring up another element that has not apparently been mentioned much, but what about like storage? Most likely probably memory for IoT devices. Do you guys think that that's that's a dimension maybe less challenging, but maybe the presence of that could help to resolve maybe some of those power versus transmission latency trade-offs.
Yeah, question on storage.
Dilemma. Yeah.
So that's really a chip question. So I'll dive in first, at least in the things component. There's a certain amount of storage that goes on in the massive servers that I'm not going to address. So today, most of the IoT is built on embedded flash, for the most part. But you're going to see a departure from that in the next few years. So eFlash is great for its use model, and the semiconductor chip companies don't like it. It's expensive, and it's very power intensive, and it's not reliable enough.
Can you execute out of it?
Yeah.
Oh,
Yeah. You can store data, or you can execute out of it.
that's nice.
Where the technologies are going, you're going to see the XRAM, as I call it, the magnetic RAM, the FRAM. TI already has chips with FRAM out, resistive RAM. And a lot of the fabs out there right now are racing to enable these things, starting at like the 40 nanometer, 28 nanometer, and below nodes. And that's where all the semiconductor guys, even in the small IoT chips, are going. So you're going to see a massive increase in the density within devices in terms of memory for program and memory for instructions or data. But it's still going to be a couple of years before those really come out. And it's going to look like flash. It's going to be even talked about still as flash, but under the hood inside of the chip, it's going to be some other kind of technology, one that scales better, one that's not as power intensive and prone to security breaches.
Yeah, I'd say from a device creator standpoint, I mean, it's a really good question. So more flash. We always want more flash.
It's coming.
So you run out of it really quick. Anybody that's developed on a microcontroller knows this, right? But the other thing is to build really cool sensor fusion type devices, you need more memory for text and for text being code and for storage, right? So yeah, I mean, the more the better, really. And I think we'll have like 1 megabits, not too far future, in a lot of radios.
And also, on the networking side, you're going to be seeing things like when on my presentation earlier, I talked about fog computing or edge computing. There's going to be that, where you're going to have a car is going to have its own set of storage. Planes do already. You're just going to see storage in a lot of things, because only so much information gets back to the big cloud. A lot of it will stay local, but you may want to access it later for records. But so you'll see a proliferation of networks. I think there's a question up here as well.
Yes, talking about standards, one of the initiatives that are taking place, it's called cellular IoT, and that's really pushing the LTE release 12 and 13 to come down to ensure quality of service, to pick up on lightweight, light load, and becoming more competition with the unlicensed type of approach. What is this being factored in your approach?
Anyone on that one?
No.
Dave? No.
I mean, as in home automation, we generally avoid LTE and stuff like that, just simply because of cost. So.
The LTE modules that they would have to implement inside of their devices are just far too expensive. I mean, LTE is really expensive. Wi-Fi is, lower cost. Bluetooth's lower cost still. I mean, it's really about cost.
We think, in most IoT applications, given the bandwidth consumption of the devices, that it's going to be used mainly as a backhaul mechanism to a mesh that sits out in a field or sits out in an area. That's where Dave's stuff can tie in, because with his technology, you need one good radio and a mesh to connect to the LTE network and get back into the network from there. So we're not sure, because the price is a big point. That's an expensive modem at this point to try to low cost into a variety of devices. I think there's questions. There we go, up here.
Before that question, I want to say just one more thing. Cost is also why you don't see energy harvesting out there.
Yeah.
Guys, remember that. I mean, energy harvesting is this mythical, awesome batteryless thing. The cost point's far too high. Batteries are still 10 or 100 times cheaper, and that's not changing anytime soon.
Right here. Yes.
Two messages were clear from the panel. One is that the things will generate very interesting data sets.
Yeah.
And the second one, that the fact that the current landscape of standards is really in flux. Given the fact that innovation most likely in this space will be fueled by being able, third parties to play with these data sets, do you see, are there already existing standards that or are there standards that will be developed, or is there will to develop that will enable interchange of these data sets between multiple parties and allow for gateways and aggregators so that you can have higher level of applications developed with what all these small things are gathering throughout the space?
So some of the protocols we mentioned, like OIC, which is the Intel Open Interconnect Consortium, that actually has some data schema to it. So there are some of these standards are about that to some extent.
We got there.
One thing in all this is, just to be clear, that the big data analysis companies, the IT is not going to happen without them. I mean, to be clear, I mean all the chip players in the world aren't going to stand up to the IBMs and Googles and AT&Ts and Amazons that are going to need to play with all of this data. So I won't say that it's solved today, but it's a necessary condition for the success of these markets.
The gentleman up here has been raising his hand since the beginning of Q&A, so why don't you go, sir?
One question about the provenance of these devices. I don't want someone that gets mad one afternoon to turn off all the refrigerators in the city of Austin. And yet you're talking about putting a device in that's going to last for 10 years or more in place in those refrigerators. What are you seeing as a developing standard to say that chip or that device has a permanent identification that is tracked just like we do vehicle identification numbers, serial numbers on blocks? It seems like that is the key to acceptance of this, where you have reliability that my things are under my control.
I'll take that. That type of technology already exists in other applications in semiconductors, especially in the chip card area. Also, the lady from TI earlier had spoken about how to create secure platforms or trusted platforms. Ultimately, for certain applications, the same needs to be unique identification for chips, and then using specific security techniques to protect the code, to make it only readable and not writable, and to protect the various ways data can be taken out of that device. So we're still application by application. That has to be determined, but there is technology today to allow that protection to prevent the scenario of turning off the refrigerators, or God forbid on a day like today, turn off the heaters.
So one of your sponsors has a question, so I think we have to let him do it, and that'll be the last question of the day.
Could you comment on the business case for manufacturing, inventories, distribution, this type of applications, please?
I know a little bit about that. There are a lot of technologies that are going to be coming to market in the next couple of years that allow indoor location tracking, which is really the hard problem because GPS doesn't work inside, down to the kind of 10 millimeter level. So it's kind of all the home automation platform providers, all the industrial optimization companies. They really need this. I'd say there's no real good low power scalable way to do this right now, but the business case is there for tracking it. It's the same thing that's been done for a while. It's why we can get avocados in the middle of the winter, and 20 years ago we couldn't. It's just going to keep going.
Okay, with that, we will wrap it up. I'd like to thank the panelists for their insights.